Find the derivatives of the following functions. So for each one of these functions, we're going to have to use the product rule. Notice here that for each one, we have two different types of functions multiplied together. So first, let's just remember what the product rule says. It says if you have one function times another, and you want to take the derivative, it will be the derivative of the first function times the second, plus the derivative of the second times the first. So let's start with the first function we have, 3x cubed times e to the 4x. First, we label our first function f, which will be our 3x cubed, and the second function g, which will be e to the 4x. We then find each of their corresponding derivatives. So f prime will be 9x squared, and g prime will be 4e to the 4x. Notice here that for g, we had to use the chain rule, or the shortcut for the chain rule, to get the derivative. So with e functions, if you have e to something more complicated than an x, it'll be the same thing back with the multiplier in front, which is the derivative of the power. Now that we have all four pieces labeled, we want to plug them into the function f prime g plus g prime f. Doing so will give us that y prime is 9x squared times e to the 4x plus 12e to the 4x times x cubed. Notice in the second term, when we do g prime times f, they both have a constant. G prime has a 4 and f has a 3. So we can combine those to get our final constant of 12. This is our final answer. For number 2, we want to do something similar. Here we have e to the 3x times natural log of x squared plus 3x minus 6. So our first function f is e to the 3x, and our second function g is natural log of x squared plus 3x minus 6. Now we want to find each of their corresponding derivatives. The derivative of e to the 3x is the same thing back, e to the 3x, with a multiplier out front, which is the derivative of the power. The derivative of 3x is just 3. For natural logs, the shortcut is that we take whatever is in the argument and put it on the bottom of a fraction. So that would be the x squared plus 3x minus 6, and in the numerator we put the derivative of whatever we put in the bottom. So the derivative of x squared was 2x, the derivative of 3x was 3, and the derivative of minus 6 is just 0. Now that we have all four pieces, again, we just want to plug it into our product rule formula. So that will give us f prime g, which is 3e to the 3x, times natural log of x squared plus 3x minus 6, plus g prime times f. So here again, okay, since we have a fraction, we can combine the f term, which is e to the 3x, with the numerator of g prime. So that will give us e to the 3x times 2x plus 3, all divided by x squared plus 3x minus 6. For our third function, we have 6x squared plus 2x raised to the 5th times the natural log of 6x. So that means our f function, the first function, is our 6x squared plus 2x to the 5th, and g, our second function, is the natural log of 6x. From here, we want to find each of their corresponding derivatives. For our f function, we want to use the outside-inside rule. So the outside derivative says to take the 5 and bring it down, because that's the power, and subtract 1 from the power. Everything inside the parentheses should stay the same. So the first part of our term is 5 times 6x squared plus 2x raised to the 4th power. We then have to multiply that by the derivative of the inside. The inside derivative would be 12x plus 2. G prime, for natural logs, we take whatever's in the argument, put it in the bottom of a fraction, that's our 6x, and the derivative of that goes on top. The derivative of 6x is just 6. So we have 6 over 6x, but we can simplify that by canceling the 6's, and we just have 1 over x. Now we need to take all of those terms and plug them into our formula to get our final derivative. which is going to be 5 times 6x squared plus 2x raised to the fourth times 12x plus 2 times the natural log of 6, that's our f prime times g, plus 6x squared plus 2x to the fifth divided by x, which is our g prime times f.